All right. Hi, my name is Conor Hoekstra. I go by code_report on Twitter and YouTube. And I work at NVIDIA just down the street, like a block from here. I work on a project called Rapids. It's open source, end-to-end data science on the GPU. If you're interested, check out rapids.ai. But that's not what I'm here to talk about. Today I'm going to talk about how across programming languages we are consistently inconsistent. So I'm a programming language enthusiast. Here is a rainbow of programming language logos. And I assume most of you weren't at meeting C++, but Diego from Conan made a point that we should be kind to our fellow programmers that don't work in C++. There are a lot of flame wars, especially when it comes to C++ versus, I'm not going to name any other languages, but their logos are up there. And the point is that we should be nice to these people. There's a lot we can learn from other programming languages, and if you are on Twitter, there was a Twitter trend recently where it had sort of 1 through 6, first language, I had difficulties with, favorite language, etc. And most people, there's a category for totally hate. And I didn't see a single person not put anything there. Because I love all programming languages, put I heart all PLs, and I encourage you to do the same. I gave a lightning talk at CPPCon just a couple of months ago called Slide and Stride, where I covered a few algorithms. These are them. I'm not going to go over this now. If you're interested, go and take a look at that lightning talk. But the idea here is I was showing sort of the same algorithm that has different names across different languages. And I sort of showed this grid, and then I highlighted it, and you can see the different colors represent different names. And then in a talk that I just gave at Meeting C++, I referred to these 3 algorithms where I did the same sort of table and then the same sort of coloring. And once again, you can see that there's sort of differences across languages. So in this lightning talk, for the next 3 minutes, I'm going to talk about a few other algorithms and how we are inconsistent across different languages. So the first algorithm we're going to talk about is the Python in. So this is when you're given an element, a list of elements, and it returns you a Boolean, true or false, whether or not that element exists in the list of elements. In dlang, we call this can-find. I think this is a really bad name. In Haskell, we call this elem. That's short for element. In F#, that's the logo there, we call this contains. I think that's a really good name. And in Racket, we call this member. So if we take a look across 12 different languages and then we highlight them, you can see that in most languages we call this contains. And if you're following standard Ds in C++20, on a couple of our associative containers, we are going to get the method, not an algorithm, but a data structure method called contain, so I think that's great. A very similar algorithm that doesn't take an element but takes a unary predicate and returns a Boolean true or false whether or not the predicate is satisfied with a given list of elements is any_of in C++. In Python they call this any, in F# they call this exists, and in Clojure unfortunately they call this sum. Once again, Clojure makes really interesting name choices. But when we take a look at the same table, you'll note that this is most commonly called any. Why is this really unfortunate? Because in C++17 we got a std any. But that's a type erasure type. So that's really unfortunate. In Scala, this is sort of the base class of their type hierarchy, and in Racket, there's a contract type. So we're not the only language that doesn't have an algorithm called any, but I think it's really unfortunate that we've done something completely different than the majority of languages. Taking a look at accumulate, this is the fold in Rust and the reduce in Clojure. This is pretty consistent across different languages. You can see here the languages that call it fold. Here are the ones that call it reduce. And in C++17, we got the modernized version of accumulate, which is reduce, so that's great. Then we have partial sum. This is more commonly known as a scan. In D, this is called cumulative fold. This is a pretty unique name, but I actually think it's a pretty good name. In Scala, we call this scan. In Clojure, we call this reductions, which I think is pretty confusing. And then in Python, we call this accumulate. So absolutely wonderful. And Rust copied Python, so we actually have 2 languages that call this accumulate. So in our sibling language, Rust, it's very confusing. This basically does not at all what the C++ accumulate does. And we actually got a C++17 version of this inclusive scan, which is, it's pretty close to scan, so I'm happy about that as well. And last but not least, we have count. So this is the algorithm name count. What does it do? So in C++, it does what you might expect. Given an element, it just counts how many of them there are. In Scala, it does the equivalent of count if in C++, where it takes a predicate and tells you how many times that's satisfied. In Clojure, it gives you the length. And in most functional languages, it actually does that. And in Haskell, it's a frequency array, so it counts the number of times each of the elements exists. So very confusing. So if we take a look, these are all the languages that it's a count if. These are all the ones it's a count. These are all the ones it's a length. And This brings me to the end, which is quoting Kate Gregory, who I think is an attendee here but isn't here tonight, that naming is hard, but in my opinion, we can do better by looking at prior art from other languages. So, thank you.